Chapter 9, problem number 73. A slender rod is 80 centimeters long and has a mass of 0.12 kilograms. A small 0.02 kilogram sphere is welded to one end of the rod, and a small 0.05 kilogram sphere is welded to the other end. The rod pivoting about a stationary frictionless axis at its center is held horizontal and released from rest. What is the linear speed of the 0.05 kilogram sphere as it passes through its lowest point? So one thing to remember is that since essentially both spheres are going to be traveling at the same speed because it's centered up. The axis of rotation is right at the center, so as fast as this goes is how fast that's going to go. Anyway, so we use conservation of energy, and we set our kinetic energy plus our potential energy is equal to our second kinetic energy plus potential energy. We have our rotational kinetic energy and linear kinetic energy equations, which is k is equal to 1/2 moment of inertia times angular velocity squared, and then our linear kinetic energy is 1/2 mass times velocity squared. So we set everything equal to 0, so we have our kinetic A plus kinetic B plus the kinetic energy of the rod plus the potential energy of A, or mass A, and mass B, and the potential energy of the rod. So we plug in the equations for Ka, Kb, Krod, Ua, Ub, and Urod, and we come out with 0 is equal to 1/2 mass A and mass A, or velocity A squared, plus 1/2 mass B times velocity B squared, plus 1/2 moment of inertia times angular velocity squared, plus mass A times gravity times L over 2 minus mass B times gravity times length of the rod over 2. Later on, we set each equal to each other. So we have basically, this is just a more complex equation of this. So we have our K1 plus potential 1, also plus the plus 1/2 of the angular acceleration, or angular velocity. Angular velocity squared, which is equal to mass, or to mass B gravity L over 2 minus mass A gravity L over 2. So we can simplify a little bit when we factor out 1/2 and multiply it by 2, then we get that the 1/2s cancel out, and so we're just left with the variables, and then we can substitute in some equations. So if we have our inertia over here, which is equal to 1/12 mass times length squared, or length of the rod squared. So we plug that in for our moment of our inertia, and then so we still have the same equation. Then we solve for our velocity, because we're trying to find the velocity of this mass, or the mass weighing 0.05 kilograms, the speed going when it's at its lowest point. So we solve for velocity, and we get the velocity equals this big chunky equation. And when we plug in our numbers for mass, gravity, length of the rod, and all those things, then we get that our velocity is equal to 1.46 meters per second.